using this concept. This concept is the fundamental, right? And I think you have already heard about KVL. Have you heard about KVL?
Yes, sir.
Yeah,
Yes,
you must
sir.
have heard about, and you must have, many of you must, I know you know about this KVL, but I'm going to teach you again. And the reason why I'm teaching you this again, because throughout my session, from the beginning to end, I will be using KVL only. And by using KVL, I will try to solve and try to find the answer of around 20 to 30 questions. So that's why I'm teaching you this again. So KVL means what? Kirchhoff's voltage law, right? So I'm going to use some sign convention here, and please try to understand the sign convention. If you are not able to follow it, then please unmute and say that, sir, kindly repeat it again. I'm ready to repeat it twice, thrice, as much as possible. So suppose you have a resistor like this, and let us call this terminal as A and this terminal as B. And the resistance of this resistor is R. And I will draw another same configuration here. Okay, let me draw it here. I'll do another same configuration here. A, B, and this is R. And I'll assume that the current is flowing from A to B in both the cases, right? A to B in both the cases. Now, suppose I'm going from A to B like this in the first diagram, and in the second diagram, I'm going from B to A. So the difference is how I'm going. In the top one, I'm going from A to B. In the second one, I'm going from B to A. Are you able to follow this?
Yes, sir.
Okay, great. Now, so the current is flowing from A to B, and we know that the current flows from higher potential to lower potential, right? So
Yes.
obviously A is the higher potential and B is the lower potential, right? Similarly here also, A is the higher potential and B is the lower potential. So I'll call this case 1, yeah, and I'll call this one as case 2. So in 1, we are going from A to B. That is, we are going from higher potential to lower potential. So since we are going from higher potential to lower potential, there is a decrease of potential. Yes or no? I'm going from higher to lower. Yes?
Yes, sir.
So the voltage, I will use this notation as, since it is decreasing, I'll give minus I into R. Fine. I'm giving minus because I'm going from higher to lower. Fine. Similarly,
Okay, sir.
when I'm going from B to A, I'm going from lower potential to higher potential. So here, the voltage will be plus IR, since I'm going to from lower to higher. Are you able to follow this? Yeah. Please try to grasp this concept, because throughout the session, I will be using this KVL to solve all the net get questions, right? So the convention which I'm going to follow is, whenever there is a resistor and when I'm going from higher to lower, then I will put minus sign. And when I'm going from lower to higher, I'm giving plus sign. Fine. The same thing you can see it like this. In the first case, the direction of your path and the direction of your current are the same. Am I right? The direction of the path, that is from A to B, it is same with the direction of the current. Am I right?
Yes, sir.
So if both the direction are same, then you can take minus. In the second case, the direction of the path is opposite to the direction of flow of current. So I'm taking plus. This is the convention which I'm going to use. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay. Yeah. Any doubt? Okay. Now what I'm going to do is I'm going to draw a power supply like this. A, B. Similarly, the same power supply I will draw A, B. So in this DC power supply, this one is the plus and this one is the minus. This one is the plus and this one is the minus. Right. Now, when I go from A to B, I'm going from higher to lower or lower to higher? Yes? Hello? Am I not audible? So when I'm going from A to B, I'm going from positive to negative. Right. So that means higher to lower. So if this has a potential of epsilon, then my voltage will be minus epsilon. And similarly here, if I go from B to A, I'm going from negative to positive. That is lower to higher. So the voltage will be epsilon. Fine. Any doubt till now?
No.
Okay. Now let us see. I know. People also use other type of sign convention, but I'm going to use this, and you'll find that by using this very basic concept, we will deal all the numericals by using KVL. Right. Now, okay, I'm going to next slide. Now, suppose, let's take a transistor. So what type of transistor is this?
NPN.
NPN. Okay, good. NPN, fine. So in this transistor, I will connect one resistor here, one resistor here, another resistor here. I'll ground this one, and I will give this some supply VCC. I'll call this one as R1, R2, R3. Fine. This circuit is fine. This is a very basic circuit. I can have a circuit like this also, but see, whenever there is any numerical base on transistor with some resistor or capacitor, right? The first thing which you have to do is there are two parts which are very commonly used. I'll call it part A and part B. So which one is the part A? So can you see this part? Yes?
Yes, sir.
Okay. Also, another part can be like this. Yes? Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now see. Maybe I can modify a bit. Okay, now I will call this one as part A. So in the part A, okay, now this part A, let me redraw it here, and I will try to simplify this circuit. So the circuit looks like this. Yes or no? Plus VCC, R1 and R3, right? Now, this plus VCC, actually this plus VCC, it will have some ground terminal, right? Yes or no? Why it will have some ground terminal? Because if this is positive, then this is measured with respect to some reference. Yes or no?
Yes, sir. Yes.
That means we can say that these two are connected. Yes or no? Yes.
Yes.
For example, I will give you another example. You must have seen some circuit like this, right? Plus 5 volt and V, something like this. Have you seen some such type of notation where only the potential is given? Yes. This is similar to this. Is similar to this. If suppose this is grounded, then this circuit is same as like this. Yeah, 5 volt. It is same as like this. Now, okay, now can you apply KVL here in this loop? Can you apply KVL?
Yes, sir.
So suppose if I apply, okay, now here to here, when I go, I'm going from 0 to positive. So it is increasing. So plus VCC. Fine. Yes. Now, since this is collector terminal, the current here, someone has unmute the mic. Can you please mute the mic? There is some background noise. Okay, the current flowing here is IC, and since it is connected to the collector terminal, and the current flowing here is IE. So here, when I go in this direction, I'm going in the direction of the current or opposite to the direction of the current?
Direction to the current.
So we will take plus IC R1 or minus IC R1.
ICR1. Minus.
Minus IC R1. Fine. Okay. Then this one is the collector terminal. This one is the emitter terminal, right? So there will be some voltage here. I'll call it VCE. So this one will be minus VCE or plus VCE. See the direction of the current. Current is flowing from collector to emitter. Are you finding difficult to identify whether it is plus VCE or minus VCE, right? So the current is going like this. Current is going like this. That means current always goes from higher potential to lower potential, right? Hello?
Yes, sir. Yes, sir.
So it will be minus VCE or plus VCE?
Minus.
Okay, good. Then what about minus IER3 or plus IER3?
Minus.
Good. Minus IERE equals 0. Fine. So this equation will be used to solve the numerical. Now I think you must have understood how you apply the KVL. Similarly, let us try to apply the KVL here, B. Suppose there is some input voltage here, right? Then if I apply in B, the equation will look like this. VIN minus IB R2 minus VBE minus IERE equals 0. Is this okay?
Okay, sir.
See, from here I'm starting. So V in. Since the current is flowing in this direction, I'm taking minus IBR2. Again here the current is flowing from base to emitter. So minus BE. Then again here right? So this is how you apply the KVL. Fine. Okay.
Okay, sir.
Now, let me show you another variant of the circuit. Have you seen a circuit like this? Have you seen a circuit like this? Suppose there is a circuit like this. And if you want to tackle this circuit, the first thing which you have to do is just name the current first. Okay, here it will be IC, here it will be IB, here it will be IE. Fine, name the current first. Then the second thing which you have to do is you can choose this part. You can choose this part, or you can even choose this part. Yes? Fine. I will call this part as C and this part as D. Can someone tell me the equation for part C? Anyone? Can you please try? Yes. Can someone try? For C, part C.
Plus VCC.
Plus VCC, good.
Minus ICR1.
Very good.
Minus IBR2.
Very good.
Minus VBE.
Very good.
Minus IER3.
Very good. Okay, can now can some other person try for part D? Please try to respond, because see, whatever you are learning now, I can guarantee that whatever you are learning now, I can guarantee that we are going to deal around 20 problems, and we'll be using the same concept again and again to solve the previous year net and get question. Yeah, part D, please.
Plus VCC.
Plus VCC, good.
Minus
Minus
ICR. Minus
R1.
ICR1.
Yes.
And
Then
VCB. VCE, sir. Minus VCE.
minus VCE. Yes.
Minus IERE.
Very good. Nice. Now, this you have learned. Now, there is also another thing which you should know while dealing the problem with transistor. Right. That is IE, you can approximately take equal to IC. This is one trick to solve it. Another is IC is equal to beta times IB. Do you know this formula?
Yes, sir. It's a gain formula.
Yes. And why I'm taking IE approximately equal to IC, because IE is given by 1 plus beta. Okay, no. This is, yeah. Now, and this one you can take approximately equal to IE. This I'm going to use it frequently. Right. Okay, now you will be surprised to know that with these two slides, you can solve most of the transistor related problems of CSIR, UGC, NET, and GET. Now, shall we solve the previous year questions? Are you ready?
Yes, sir.
Okay. Now, yeah, let's start. First of all, you please read this question properly. I will give you 1 minute time to read this question. This was asked in GATE 2012. If you want, you can have a copy and pen, and if you can solve it, you can proceed it. If you don't know how to solve it, please try to listen. I will explain it. Okay, have you read this question? So the question says that in this circuit, the beta DC, that is beta value is 100. And which one of the following correctly represents the load line? Okay, and in the actual question, they have given 4 options, but I am not showing you the option here, right? So first of all, this load line, when you say the load line, it is a plot of IC versus VCE, and it is a DC load line. So the graph will look something like this. So this point we have to identify, as well as we have to identify another point known as a Q point. Right. So if you can identify this, then you have the information of the load line and the Q point of this circuit. Right. Now, what is on the y-axis? IC. And on the x-axis, we have VCE. Okay. So now this is the circuit. The first thing which you have to do is just name the current. So this one will be IB. This one will be IC. Second, IC. And this one will be IE. Fine. Is this fine?
Yes, sir.
Okay. So I think it is because if I take this loop, the one, I will have the information of IC and VCE. Yes or no?
Yes, sir.
Okay. Can someone tell me the equation? Yes. We can start from here, right? So it is VCC minus, 15 volt. But for now, I'm just writing the symbol. Minus IC 900 minus VCE
VC
minus IE 100. Fine. Yes or no?
Yes, sir.
Okay.
Yes.
Now see how many variables are here in this equation. One here, and one here. Fine. 3. But I can reduce it to 2. How? I can take IE approximately equal to IC. Yes or no?
Yes, sir.
Then VCC minus IC 900 minus VCE minus IC by 100 equals 0. Yes?
Yes.
Now, then I can write VCE is equal to VCC minus IC 900 plus 100. Yes or no? So this becomes VCC equal to IC minus IC 1000. Yes?
Yes, sir.
Now, okay. Now, in this equation, put If I put IC equals 0, then I will get this point. Yes or no? Yes. Because on the x-axis, IC is equal to 0. So when I put IC equals 0, VCE is equal to VCC, that is 15 volt. Yes?
Yes, sir.
So now this point is 15, 0. Yes or no? Yes? Similarly, if I put VCE equals 0, what is IC? IC is 15 divided by 1000, that is 15 milliampere. Yes or no?
Yes, sir.
That means what is this point? Point is 0, 15 milliampere. Fine. Yes or no?
Okay, sir.
Now,
Yes, sir.
we have found out these two intercept, but we need to find the quality point also, right? So what is this quality point? This is, the Q point. This Q point. Okay. So what is this Q point? Q point is basically it is the operating point. Operating point, right? Operating point. So in order to find out the operating point, what we need to do is, first you need to find out IB. But again. Okay, first you need to find out IB. After finding out IB, you find IC by using the formula beta times IB, and using this IC you find out VCE. This is the process, right? Shall I rephrase it again? For finding out the Q point, first you have to find IB. Then for using IB, you find IC. Then using IC, you find VCE using this formula. Okay, can someone tell me how can I find IB? Can I use this loop? Yes or no?
Yes, sir.
Okay, can someone tell me the equation for this loop?
VCC minus
VCC minus
IB 100,
100K.
100K, sorry.
Sir,
Minus
beta point is given. Sir,
Yes.
beta point is given. So from direct beta, we can measure the IB, no, and IC we know already.
No. Beta point means.
Beta is given.
Uh,
So from there.
no, beta is given, but you don't know the IC value, right? You know only the IC at the extreme. You don't know the IC at this point, right?
Okay.
Then, okay, someone was saying IB into 100K
minus VBE
minus VBE.
minus IE 100K. Sorry, 100 ohm.
100 ohm. Okay, now you want to find out IB, right? So this IE, can you replace by beta into IB? This, in this equation, this IE, I can replace by beta into IB, yes or no?
Yes, sir.
Yes.
Yes.
Okay, from this equation, can you solve IB? Yes or no? Okay, there is a problem. What is the problem?
We need to find VBA. We don't know.
Yeah, good. Remember, everyone, please try to listen carefully. VBE. VBE is nothing but the voltage across the base and the emitter, right? And this will act like a diode. So you can take 0.7. In most of the numericals, you can take this one to be 0.7 until yeah, means you can take 0.7.
Okay.
So now can you solve IB?
Yes, we can,
Yes
sir.
or no?
Yes, sir.
After solving IB, can you get IC using this formula?
Yes, sir.
Then using IC, by using this formula, can you get VCE?
Yes, sir.
That particular IC and VCE is this point. Fine.
Can you repeat again?
Okay. From here, you are getting IB, right?
Yes, sir.
And using this formula, can you find IC?
Yes, sir.
Then by using this IC and by using this formula, can you find VCE?
Yes, sir.
Now that IC and VCE is what the Q point is. Fine.
Okay, sir.
Now don't try to get confused with this IC and VCE. These 2 points are the intercept. But the calculated point here, IC and VCE, these are the operating point. Okay, any doubt? Shall we move on to next question? Hello. Okay, moving on to next question. Okay, now the circuit seems to be a bit complicated, right? Because we have an additional 2 capacitor. Yes or no?
Yes, sir.
Yeah. But you know the formula of the reactance of a capacitor, right? Xc is equal to 1 by omega c, right? So this is for DC. So in DC, omega tends to 0. So since omega tends to 0, Xc will tends to what? Xc will tends to
Infinity.
infinity. Good. So if Xc tends to infinity means for the DC analysis, we can remove this. Now the equation looks simpler. Yes or no? Now,
Yes.
what is the question asking? The question is asking, find the value of the collector current. This is what you want to find out. So, can we use this loop? Yes. We can either use this loop or we can even use this loop. We can use both the loop also. Shall I show how to use both the loop? Okay, let me try with this one. I will call this one as A. Now, for the loop A, what is the equation? Yes, anyone? This is IC, this is IB, and this is IE. So can someone tell me the equation of loop A?
VCC minus
Yeah, okay, 12 volt minus
12 volt minus IC3K
IC3K
minus IB 150K
I think it is 150. Then
minus VBE
VBE, then
minus I3K.
3K. Okay, now this equation, can I all convert to in terms of IB like this? Beta times IB 3K minus IB 150K minus VBE minus beta times IB 3K. Yes. What is the value of VBE? Can I take to be 0.7? Now, from this equation, can you solve IB? Yes or no?
Yes, sir.
What about others? Can you solve IB using this equation?
Yes, sir.
Yes, sir.
Okay, once you get IB, you can get IC like this. Finish. Done. Problem solved. Fine. Any doubt?
No, sir.
Okay, fine. So we move on to next question.
Sir, with
Just
150K, that is,
Sorry.
hello,
Yeah.
that register with 150K, it will be with IB or with IC.
Which one? Which one?
That register 150 kilo
This one will be with IB.
IB.
Yeah, B.
Okay.
Okay, I'm moving on to next
But
question. Tell
it
me.
is actually connecting towards from the, it is directly connecting to IC. That's why I thought of that.
No. This one we are calling it IC. Then from here, some went here and some went this side. Whatever current has gone here, we are calling it IB.
Okay.
Fine. Okay. Now this is very interesting. Now you might think that, okay, the circuit now looks more complicated than whatever we have done till now. Yes or no? Yes. The circuit
yes,
looks
sir.
more complicated, right? Now let us try to break down this circuit. The potential at here and the potential at here are the same or different?
Will be the same.
Same.
Same. So that means the collector and the base are in the same potential, are at the same potential, right?
Yes, sir.
So that means this transistor will not play any role. Can I say it like this? Because for getting the transistor action,
Repeat once again.
okay, these two potential are the same, right? So the base and the collector are short circuited, means they are connected. Yes or no?
Yes, sir.
So that means this Q1 will not play any role here. We can neglect this one. Now, actually, there is a mistake here. They are asking the current I naught, but see, can I take a part here like this? Can I take this part?
Okay, sir.
Okay. Now in this part, whatever the current it is flowing, that is the answer for this question, right? So, okay, now tell me the equation. This one is IC, and the same IC is flowing here. So can I write 30 volt minus IC 5K minus VBE equals 0? Can I write like this?
Yes, sir.
Yes. Can I write like this? So
Yes.
Yes, sir.
from here, can you solve IC?
Yes, sir.
That is the answer. Okay, we have more question to solve. We are going to discuss op-amp also. So if you are feeling comfortable with such type of problem, shall we go to next? Can we speed up a bit faster?
What is I naught, sir?
Sorry?
Yes, sir.
I not actually, they are asking for the current source, but the current source cannot be calculated like this. Actually, the IC should be the answer.
Sir,
Okay,
that
we
IC
are,
is equal to IB for Q2, sir.
yes, yes, yes. Because here, if you see, this is the less resistive part. So it will try to go here. Current will always try to go to the least resistive part. Okay, we are moving on to next question. Okay, read this question and say whether you will, can you solve this or not? If you can solve, we can move on. Okay, I think this is a little bit different, but see, they are asking what? V output, right?
We out.
Yeah, they are asking V output. Yes. So how you solve this? See, I can take a loop here because V output will be measured with respect to the ground. Yes or no?
Yes, sir.
Here the current is IC. Yes. So to find out the V output, I need the information of IC. Yes or no?
Yes, sir.
Yes, sir.
But if I use this loop, which is nothing but IB and IE, from this loop A, I can find out IB. Yes or no? Using loop A.
Yes, sir.
Yes? Yes or no?
Yes, sir.
Yes, sir.
Then I can find IC using beta times IB. Yes?
Yes, sir.
Then using this loop B, using B, I can find out V output. Are you able to follow this? Do you want
Yes,
me
sir.
to solve or shall we move on to next numerical?
Sir, V output is equal to VCE also.
No, no. Why? Because VCE is the potential difference between this terminal and this terminal. V output is VC and the ground. There is a difference. Okay. Do you want me to solve or do you want me to move on to next question? I wanted an opinion.
So move on to the next.
What about others?
Sir, solve it, sir.
Yes, sir.
Solve it. Okay. Can I get some more opinion?
Yes, sir. Please
Yes.
solve it, sir.
Okay, good. You should respond like this so that, okay. Now, let us use loop A. So can someone tell me the equation?
Yes, sir. 10 volt
See,
minus.
okay,
Oh.
5, no,
Loop B.
B input is 5.
5
5
minus
minus
IB
IB
200
200K
200 VB minus VB
minus VBE
minus I 1 kilo.
IE 1K. Yes or no? So this IE,
Yes, sir.
I can convert it into IB, right?
Beta IB.
So yeah, 5 minus IB 200K minus VBE minus beta times IB 1K equals 0. Now from this equation, can I solve IB?
Yes, sir.
Yes.
Now once I get IB, I can get IC. Using this formula. Yes or no?
Yes, sir.
Yes, sir.
Okay, now what about loop B? Can someone tell me the equation? Yes,
Yes, sir. 10 volt
yes,
minus
minus,
3 kilo ohm into IC
yes,
minus V out.
very good. Now, from here, can you solve 10 minus IC by 3K? Using this relation, since you already know IC, from here, you can substitute it here. Yes?
Yes, sir.
Yes, sir.
Okay. Now, can I move on to next question?
Yes, sir.
What about others? Are you able to follow what I am teaching?
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Sir.
Okay, great. This one actually, there was some difficulty with the circuit. I'll just draw the circuit and tell me whether you will be able to solve it or not. If you can solve it, we'll move on. Yeah, can you solve this? in the following circuit development for application vector is Z, and you have to find IB. Can you solve this? What will happen to the capacitor? We are doing DC analysis, right?
Yeah, so we can cancel.
Yeah, we can cancel this one. Now this one will be IB, this one will be IC, and this one will be IE. Yes?
Yes, sir.
Sir, is there any hints in the question that here we are using DC? Okay. DC voltage is there. Thank you.
So we can use this part. Can we use this part?
Yes, sir.
Sure.
Yeah, by using this part, can you solve IB? Okay, just tell me the equation. Can someone tell me? Just try. Even if there is a mistake, it's fine. Just try. Anyone? Tell me the equation.
20/7 minus 500 IB 500K
Yes.
minus VBE
Okay.
minus IE 1K.
Okay. So now what you can substitute here? Yes. How you'll solve for IB? What is the value of VBE?
0.7.
0.7.
Okay. And IC, what you can write?
Beta into
Beta AB.
IB. Yes. Now can you solve for IB?
Yes, sir.
Okay, very good. Shall we move on to next question?
Yes, sir.
Okay, now this was asked in NET 2019. Now see, the circuit is something different from what we have done earlier, right?
Yes, sir.
But don't worry, you just have to apply the same rule, right? You just have to apply the same rule. That's it. Now let us try to break down this circuit. Okay, there is an NPN transistor and it is connected in voltage divider circuit because two transistors are here as shown in the figure below. If the resistor R is disconnected, actually this should be R2. R2 is disconnected, then the voltage, okay, V at the base and V at the collector changes as below. That means they are asking what will happen to VB and VC. Fine. Understood the question? Can you please read it again? I will give you 1 minute time. Please read the question. Have you read the question?
Yes, sir.
They are saying that they are removing this R2. This one they are removing. Then they are asking how will VB and VC changes, right? Whether they are increasing or whether they are decreasing. This is the question, right? Okay.
Yes, sir.
Now, before this, I would like to explain something. I hope you all know this because Suppose if there is two resistors connected in series, R1 and R2, then V1 is equal to R1 divided by R1 plus R2 into V. Do you know this?
Yes, sir.
What about others?
Yes, sir. So voltage divider.
Yeah, voltage divider rule. Similarly, V2 is equal to R2 by R1 plus R2 into V. So if you know this VB, voltage at the base, now my first target will be, I will try to find out VB. This is my first target. Now, please see this circuit. Can you see the circuit?
Yes, sir.
Now, this circuit, can I write it like this? Can I write it like this?
Yes, sir.
What about others?
Yes,
Are
sir.
you able to follow this?
Yes, sir.
Okay, now here, whatever voltage I am getting here, V2, this voltage is applied at the base. Yes or no? If you
Yes,
see
sir.
this voltage here, this voltage is what it is applied at the base. Yes or no? Because if you want to find out the voltage at this point, then you have to measure it with respect to the ground. So this voltage is nothing but the voltage across R2. Yes or no?
Yes, sir.
Okay, now can I write VB is equal to R2 divided by R1 plus R2 into VCC? Can I write like this?
Yes, sir.
Using this trick? Yes or no? So I can remodify and write it R1 by R2 plus 1. Can I write it like this? Yes or no?
Yes, sir.
So when R2 increases, what will happen to VB?
VB will increase.
Are you sure?
Yes, sir.
It will decrease.
Oh, please see it carefully. If R2 increases, this factor will decrease. If this factor decreases, whole factor will increase or decrease.
Sir, the whole factor will increase.
Yeah, it will increase. It will increase. Right. So VB will increase. So out of this four option, which one has VB increase? So either the option will be A or D. Yes or no? Yes.
Yes, sir.
Option A.
Yes. Yeah, it will be option A or D based on whatever we have done till now. Right.
Okay, sir.
Now, what about DC? Can any one of you give any suggestion?
So because of VB,
See,
the potential drop will also increase in VC.
because of VB, but see, you can get the information about VC from IC, right? So because let me show you one trick. There are many ways to solve this one, but let me show you one trick. Now, VBE is equal to VB minus VE. Yes or no? Yes. So from this, can I write VE is equal to VBE minus? Can I write like this?
Yes,
Yes
sir.
or no?
Yes, sir.
So if VB increases, what will happen to VE? It will also increase.
Yes, sir.
But if VE increases, what will happen to IE?
Increase.
Because IE is equal to VE by RE. Yes or no?
Yes, sir.
So that means IE also will increase.
Yes, sir.
If IE increases, what about IC? This will also increase. Because they are approximately same. Yes or no?
Yes, sir.
Okay, now finally I got about IC, that is, it is increasing. Now can you please focus on this circuit? If IC is increasing, that means the drop at this point will be higher or lower. It will increase or decrease. Current flows from higher to lower, right? Current flows from higher to lower. If more current is flowing, that means the potential here will be lesser. Yes or no?
Yes, sir.
So VC is increasing or decreasing?
Decreasing.
Decreasing. Yes. So what is the correct answer?
Option D.
D.
No, option D, right? VB is VB is increasing, right? VB is increasing, and because of this, VC is decreasing. Okay. Shall we move on to next
Yes, sir.
topic? What about others?
Sir, VC
Yes, sir.
part, I get it. VC part.
Which part?
VC, why VC is decreasing? Just one repeat.
See, IC is increasing, right?
Yes, sir.
If IC is increasing and current flows from higher potential to lower potential, more current is flowing, that means the difference
Oh,
is more. Like that also
it's
you
deep.
can give an argument. Okay.
Ah,
Okay. Now, okay. Now what we can do is, okay, we have around 30 to 40 minutes. Okay, I just want to teach you some basics about diodes. It's very easy. those basic, by using those basics, we are going to solve 3 to 4 numericals on diode. Then we will op-amp. Is that fine?
Okay, sir.
Yes, sir.
Okay.
Okay,
Do you
sir.
want to take some 5 minutes break or what? Shall we continue?
Continue, sir.
We can continue, sir.
Continue.
Okay, fine. So now remember this. This is a simple example of a PN diode. This is what we call as P. This one is what we call as N. Now, if P is connected to higher potential and N is connected to lower potential, we call it forward bias. Yes or no?
Yes,
It's
sir.
a forward bias. Ideally, we said that the circuit is on. Yes, in ideal case. Now, in some of the cases, if it is silicon, we just replace it with a voltage source of 0.7 volt. If it is germanium, we replace it with 0.3 volt. Try to understand this logic. Whenever a diode is forward bias, that is P connected to higher potential and connected to lower potential. In ideal case, we just short circuit it. If it is a silicon diode, we just put it 0.7. If it is a germanium diode, we put it 0.3 volt. Fine. Okay. Now, if the P side is connected to lower potential and N side to higher potential, then we call it reverse bias. In this case, it is an open circuit and we call it off. Yes or no? Yes.
Yes, sir.
Okay. Now, see, I will start with some simple circuit, then we will go to some complex one. Now, if I connect, I will start with a basic example. Okay. Maybe I can wait. Suppose this is 8 volt and this is given as silicon, and let's say this is 2 kilo ohm. What will happen? So it is forward bias or reverse bias?
Forward.
Forward.
Yeah, it is forward bias. So what you can do is you can just replace it, the silicon diode, with what? 0.7 volt, and you can connect it like this. Fine. Yes. Now, if you are asked to find a current, can you find a current? Just use the KVL. Can someone tell me the KVL equation if you go in the loop like this?
Plus 8 minus
Yes.
0.7
Hmm?
minus 2 Ki.
Yes. From here you can find out this one. And what is the voltage across the diode? Yes.
0.7.
0.7. And what is the current through the diode? Yes. It is the same as I because they are in series. Okay, now
7. Okay, yeah.
what if I reverse it like this? Yes. What will happen? Diode is forward bias or reverse bias?
Reverse bias.
Yes. So it will act as an open circuit and no current will flow.
Okay, so it will act like this. Yes. So what is VD?
Minus I put.
VD, it will be minus or plus?
Minus.
Okay, let us apply the KVL in this direction. 8 minus VD minus 0 into 2K is equal to 0. Yes or no? Yes. So from here, VD is equal to 8. Right. Fine.
Yes,
Okay. Now, let us try to suppose you are told to find out the output voltage as well as ID. And they have given that this one is silicon and this one is germanium. Fine. Now, tell me, both are forward bias or reverse bias?
Forward.
Forward bias. So
Forward
what you
bias.
can do, what you can do is you can just replace them with two voltage source like this, one of 0.7 and other of 0.3 volt. Okay. The resistance we can just take 5K. Okay, how you'll find out the output voltage? Just apply the KVL here. Then you can find out the current I. Once you find out the current I, you can find out the voltage across 5K is nothing but V naught only. Yes? Yes or no?
Yes, sir.
So apply KVL. 12 minus 0.7 minus 0.3, then minus V naught is equal to 0. Then you can get V naught is equal to 12 minus 1, that is 11 volt. Fine? Yes or no?
Yes, sir.
What about I? Is like this. With this, you can solve it. Yes? Now, what suppose if the circuit is like this? Yes? Now you tell me, which one will be on? Which one will be off?
Silicon is on.
Germanium is off.
Yes, sir.
Or both will be off.
Both will be off because it's in
Because see,
series.
yeah, it's in series. If germanium is off, then no current will be flowing in this part. So both will be off. Remember this. Right? Fine. So what is the voltage across the germanium diode? Yes?
0.
Will it be 0?
Sir, 12 minus V naught.
How much is V naught?
Sir, 11 volts.
Why? Is there any current flowing through the 5K register? Is there any current flowing
No,
through
sir.
the 5K register?
No, sir. No, sir. Not in this
So
case.
yes. So the drop across the germanium will be how much? 15 volt, 12.
12 volt.
Yeah. Okay, now let us see some parallel circuit. Till now we have been dealing about the series circuit. Now suppose
Sir, it
if
will be 0.3 something, right, sir? Silicon will be silicon diode will be there.
but no current is flowing to that through that silicon, right?
Yes, sir.
If no current is flowing, then how can we replace with 0.7?
Yes, sir.
Okay, now what about this parallel circuit? Okay, 0.3 K, and I will call this one as D1, this one as D2. And remember this, whenever there is a parallel combination of diodes, either it will be mentioned in the question that both the diodes are identical, or if it is not mentioned, then you can assume it that both the diodes are identical. Suppose if it is silicon, then you can, even in silicon also, there can be some difference in the characteristic. So until and unless it is mentioned in the question that they are not identical, you can assume that they are identical. Fine.
Yeah.
Okay,
Yes, sir.
so both are silicon. Now, so tell me whether they, now let us try to find out ID1, ID2. See, whatever exercise I'm doing right now, they will be all useful to solve your this net and get numericals. So these are the question which is asked. Let me draw here. This one is I1. This one is ID1. This one is ID2. This one is V0. So the diodes D1 and D2, both will be on or what?
On, sir.
On, sir.
On. So can I replace the whole circuit like this? Can I replace the whole circuit like this?
Yes.
So this one is I1, ID1, ID2. Okay. Can someone tell me what is V0?
Thanks, sir.
See, V0 is the potential across these two terminals, and it is nothing but the potential across the D2 terminal. Yes or no?
8.6 volt.
No. See, V0 is the voltage at the output, and output is nothing but the potential across the diode D2. Yes or no?
Yes, sir.
So what will be V0 here?
0.7.
0.7 volt. Yes. Okay, we have got V0. Next. Can you find I1? Use this loop.
So 3.1 milliampere.
Yeah, you use this loop, the outer loop. Can someone tell me?
3.1 milliampere.
Yeah. Can someone tell me the KVL equation of this outer loop? Yes.
10 minus 0.3
10
K
minus
I1
I1 0.3 K
minus
minus
0.7.
V naught. So from here you can find out
Zero.
I1. Yes or no? Yes. Now the current I1, which is coming here, it is divided into these two parts. Yes or no? Now, if you assume that both the diodes are identical, then this I1 will be divided equally between these two. Yes or no? Yes.
Yes, sir.
So if it is equally divided, then can I say that ID1 is equal to ID2, which is equal to I1 by 2. Can I write it like this?
Yes.
Now, if I give a circuit like this, I will just draw a circuit here. Maybe I can rub this one. If I give a circuit like this, will you be able to solve it? I'll just call it R1 and R2. Can you solve this? Now, both the diodes will be forward bias or reverse bias? Yes.
Forward bias.
Forward bias. See, you can see it like this: 0.0, like we require a minimum of 0.7, and the voltage is 20 volts. So obviously both will be forward bias. So what we can do is we can just replace this circuit with this circuit. $20 volt, 0.7 volt, 0.7 volt. This is R2 and R1. Now, if they ask anything, like if they ask, let's say, if they ask ID, suppose this is D1 and this is D2, ID1, ID2. Can you find out? Yes or no? Hello? Okay, now, hey, one more concept I want to discuss about Jenner diode, then we will move on to the previous year question papers. Now, can someone tell me what is a Jenner diode? Yes?
It is used as a voltage regulator.
voltage remains constant across it.
Okay. Now remember this. Zener diode. This is a special purpose diode. When it is forward bias, it is same or not same, I should say, similar with the normal PN diode. Remember this. Zener diode, when it is forward bias, its characteristic is similar to that with the normal PN diode. But when it is reverse bias, then there will be breakdown due to Zener breakdown mechanism. Now, if you see the normal IV characteristic, then if suppose this is the normal PN diode, but in the case of a Zener diode, the breakdown will be at lower voltage like this. And this is characterized by VZ. Right, fine. Now you should understand this. In the breakdown, in this voltage, you can see that the change in the current is very large, but the voltage across the diode is almost constant. And this feature is exploited for making a voltage regulator. Now, this is the part which you should focus. Suppose this is a Zener diode. Suppose you have connected this to the negative and this to the positive. Right? So now the Zener diode is forward bias or reverse bias?
Reverse, sir, reverse.
And suppose this voltage V, if it is greater than or equal to Vz, then means only under this condition, breakdown condition, that is the voltage. Please try to note this. Whenever there is a problem related to Zener diode, you have to check the voltage across these 2 points. It should be at least the Zener breakdown voltage, right? Then if this is satisfied, then what you can do is you can replace the circuit like this. Can you see the difference here compared to PN diode? Can you see some difference here?
Sir, it is not getting off.
No. If you see the difference in the normal PN diode, when it was forward bias, P was met positive and N was met negative. Can you see the difference here?
Yes, sir.
I will write it down. For the normal PN diode, if P is connected to positive and N to negative, we were replacing it like this. Positive and negative. Can you see the difference between this and this?
Yes, sir.
Yeah. Now, suppose if you are given a numerical on Zener diode, suppose, let's say, I will give you an example that will help you. Suppose if you are given a numerical like this, let's say you have a circuit like this. a Jenner diode to this, and let's say a load resistor. Suppose this is the circuit, and here they have given VGen. See, in Jenner diode, they will always mention the value of VGen. Fine. Yeah. So what you have to do is you remove the Jenner diode. This is the proper way to do it. Remove the Jenner diode. After removing it, you calculate the voltage, this voltage. Yes. And check whether this V1, if it is less than VZ, or V1 is greater than or equal to VZ. If this is the case, then you make it open circuit. And if this is the case, you just replace it the VZ source like this. Can you understand this?
Yes, sir.
Right. Okay. We are running out of time. I will solve this question, and maybe we can, because we have another session also. And we, when is your next session? It's at 11:30, right? Hello.
Yes, sir. Yes, sir.
Okay, then we will solve this question and we will wind up the session. Right. I will try to find out some time so that we can discuss for op-amp also. Now see, how many Jenner diode we have here?
2 Jenner.
So you remove these two. You remove these two, and you try to find the voltage across. I will call it V1, and try to find out voltage V2. Then you can check. And this looks very difficult, but it's just 1 to 2 line solution. I will demonstrate it how. So this is open circuit now. You have one more circuit here. You have one open circuit here. This one is 2K, this one is 1K, and this one is 500 ohm. Okay, 30. Now, can someone tell me the voltage, this voltage? This voltage is nothing but the voltage across the 2K, right? Yes. Hello. Yeah, this
Yes,
is the
sir.
last question. After this will end. So can I write V2 is equal to K plus 1K plus 2K plus 0.5K into 30. Can I write it like this?
Yes, sir.
This is just a voltage division rule because this circuit is equivalent to this circuit. $30 500 1K 2K. This is equivalent. So by using this formula, you will get V2 to be around 17.14 volt. What is the voltage rating of this diode? Jenner diode? 10. So you are getting around 17.4. So this one will be in the breakdown or it will not be in the breakdown?
Breakdown.
Breakdown. Similarly, can you calculate this voltage here? It is the voltage drop across these two resistors. Yes or no?
Yes,
So
sir.
this V1 is nothing but 2 plus 1 divided by 1 plus 2 plus 0.5 into 30. You'll get around 25 approximately. So here also you are getting 25. And what is the rating here? 20 volt. So this one also will be in the breakdown. So since both the diodes are in breakdown, now you can draw your final circuit. So what is the question asking? The question is asking what is the current and the voltage across 2K. What is the voltage across this? See,
17.1.
no. The voltage across this is nothing but the voltage across this.
10.
Yes or no?
10 volt.
10 volt. So voltage across 2K is 10 volt. And what about the current across 2K? It will be 10 volt divided by 2K, which is nothing but 5 milliampere. Okay.